Welcome to the 6th lecture of Industrial Safety and Maintenance Management course. In this lecture, we will be discussing about the mechanical injuries, how machineries can become a reason of mechanical injuries, what hazards are associated with the normal operations of the machine, and how we can prevent the effects of these hazards to human beings. Now starting our lecture about mechanical hazards. So what are mechanical hazards? Machines have moving parts. The action of moving parts may have sufficient force in motion to cause injury to the people. Mechanical hazards are those associated with power-driven machine, whether automated or manually operated. Machines driven by hydraulic or electric power. Frequency of mechanical hazards. Based on the data collected on injuries and death in the workplace, injuries caused by machinery represent second highest number. Mechanical hazard statistics. Improper or non-existent guarding and lockout of machines and equipment can result in disfiguring injuries, amputation, and deaths. In the Workplace Safety and Insurance Board, statistical supplement to the 2010 annual report, following information was reported for 2009. 217 lost time injuries claims for caught in and compressed by equipments. 427 lost time injuries for rubbed or abraded by friction, pressure or jarred by vibration. 361 amputations, that is 361 injuries resulting in loss of body parts. Mechanical hazard statistics. Improper or non-existent guarding and lockout of machines and equipment can result in disfiguring injuries, amputation, and deaths. In the Workplace Safety and Insurance Board statistical supplement to the 2010 annual report, following information was reported for 2009. 2,171 lost time injuries claimed for caught in and compressed by equipments. 427 lost time injuries were for rubbed or abraded by friction, pressure or jarred by vibration. 361 amputations were recorded, that is 361 injuries resulting in loss of body parts. Mechanical injuries. In the industrial setting, people interact with the machine designed to drill, cut, shear, punch, clip, staple, stitch, abrade, shape, stamp, and etc. If workers fail to follow safety precautions, these procedures can happen to human instead of workpiece. The types of injuries results are straining. A strain results when muscles are overstretched or torn. It can cause swelling and intense pain. Cutting. A cut occurs when a body part comes in contact with a sharp edge. Seriousness of cutting or tearing depends on damage done to the skin, veins, arteries, muscles, and even bones. Shearing. Injury occurs when mechanical force that acts on an area of the skin in the direction parallel to the body's surface. Its intensity depends upon pressure exerted. Crushing. Crushing injuries occur when a part of a body is caught between hard surfaces that progressively move together, crushing anything between them. Body parts can also be crushed by a heavy object falling on a foot, by a hammer hitting a finger, etc. Breaking or fracturing. Machines used to deform engineering material in a variety of ways can also fracture or break bones. Puncturing. Puncturing results when an object penetrates straight into the body and pulls out straight, creating a wound in the shape of a penetrating object. Entanglement. For example, a loose sleeve getting caught in a moving part and drawing the person's hand into the machine. Potential spots for mechanical hazards. When reviewing machinery and equipment for possible mechanical hazards, consider machines and equipment with moving parts that can be reached by the people. Machines and equipment that can eject object, parts, component, product and waste item that may strike a person with sufficient force to cause harm. Machines or equipment with moving parts that can reach people such as booms and mechanical arms. Mobile machinery and equipment such as forklift, pallet jacks, earth moving equipment operated in areas where people may gain access. Now let us discuss some mechanical injuries so you become better aware of this mechanical hazard and take better care of yourself in future. A worker was oiling a conveyor belt while it was running. The shaft, located in a little out of the way, rotated so slowly you could barely see it move. The worker didn't notice his fanned leg becoming entangled with the shaft, which was heavily coated with the paint. By the time he felt the fabric of his coverall tightening around his ankle, it was too late. He was working alone, and all he could do was to hold on as his leg was torn off below the ankle. Another mechanical injury involves the entrapment of a worker in a box. A production worker was pinned by a control arm and pulled into a box packaging machine where he suffocated, despite of different attempts made by his co-worker to rescue him. This 31-year-old man was married and has 2 children. An experienced worker became entangled in an unguarded roller machine and was crushed to death in a matter of moments. She left behind a husband and 2 small children. Risk assessment on machine operation. Risk assessment should be structured, systematic, and answer 4 specific questions. These questions include: how severe are the potential injuries? How frequently are the employees exposed to potential hazards? What is the possibility of avoiding the hazard if it does occur? What is the likelihood of injury, including the case where the safety controls fails? Hierarchy to minimize mechanical hazard. Hierarchy to minimize any hazards involve eliminating the hazard and then preventing the human beings from that hazard. Finally, we control the effects of any hazard. Same goes with the minimization of mechanical hazard. First, we try to eliminate the mechanical hazard. That is, if the machine or equipment is not essential to the experiment or project, eliminate it altogether or engineer it out. Prevent. If it is not possible to eliminate the hazardous machine, then guard it. Control. Also, if it is not possible to install guards, then last option to rely on is training of the personnel and personal protective equipments. Machine guards. A guard is a barrier that prevents entry of any part of the body into the hazardous area. The National Safety Council defines safeguarding as: machine safeguarding is to minimize the risk of accident of machine operator contact. Types of guards. Safeguards can be broadly categorized as fixed guards, interlock guards, adjustable guards. Fixed guards. As the name implies, a fixed guard is a permanent part of the machine. It is not dependent upon the moving parts to function. It may be constructed of sheet of metal, screen, wire, bars, plastic or any other material that is substantial enough to withstand whatever impact it may receive and endure its prolonged use. Fixed guard is usually preferable to all other types because of its relative simplicity. Advantages of the fixed guard. It can be constructed to suit many specific applications. Also, in-plant construction is often possible. It provides maximum protection. It usually requires minimum maintenance. And it is also suitable for high production and repetitive operations. Disadvantages of the fixed guards. They may interfere with the visibility and can limit to specific operations or machine for which they are constructed. Machine adjustment and repairs often require its removal, thereby necessitating other means of protection for maintenance personnel. Interlock guards. When this type of guard is opened or removed, the tripping mechanism and the power automatically shuts off. The moving parts of the machinery are stopped and the machine cannot be started until the guard is back in place. An interlock guard may use electrical, mechanical, hydraulic or pneumatic power or any combination of these. Placing the guard again shall not automatically start the machine. Advantages of interlock guards. These guards allow safe access to the machine for removing jams or to conduct routine maintenance without taking off guards. Disadvantages of interlock guards. These guards require careful adjustment and maintenance, and in some cases they can be easily disengaged. Adjustable guards. Adjustable guards are useful because they allow flexibility in accommodating various sizes of feedstock. Advantages. They provide a barrier against a variety of hazards that are associated with different operations. They can be adjusted to admit varying size of feedstock. Limitations or disadvantages. Hands may enter the danger area. Requirements for all kinds of safeguard. National Safety Council's requirement for safeguards includes: prevent direct contact. Safeguards should prevent human contact with any potentially harmful machine parts. Create no new hazards. Safeguards should overcome the existing hazard without creating the new ones, that is, sharp edges, unfinished surface, or protruding bolts. Be secure and durable. Nobody may render them ineffective by tampering with or disabling them. Must be durable enough to withstand severity conditions at the work. Create no new interference. Safeguards that interfere with the progress of work are likely to be disregarded or disabled by the workers, feeling the pressure of production deadlines. Protect against falling objects. Objects falling onto moving machine mechanisms increase risk of accidents. Guards should shield moving machine parts from falling objects, which can hurtle out, creating a projectile. Allow safe maintenance. More frequently performed maintenance tasks should be accomplished without removal of guards. If possible, one should be able to lubricate the machine without removing the safeguards. Lubricating oil reservoir outside the guards with a line leading to the lubrication point will reduce the need for the operator or the maintenance worker to enter the hazardous area. Machine safety responsibilities, that is, responsibilities of the management, supervisors, and operators to ensure the proper use of the safeguards. Management should ensure that all the machineries are properly guarded. Supervisors should train their employees on specific guard rules in their areas and should ensure machine guards remain in place and are functional, and immediately correct the machine guard's deficiency. Employees. It comes under the responsibilities of the employees to not remove the guards unless machine is locked or tagged, and report machine guards problem to the supervisors immediately. Also, do not operate the equipment unless guard is in place. Machine safety devices. A safety device is a machine control which prevents or interrupts the operation if the part of an operator's body, such as hand, is within a hazardous area. These safety devices require the withdrawal of worker's hand prior to the machine operation. The example of such devices includes automatic doors in the markets and elevators. Different types of safety devices which are present in market involves restraint devices and pullback devices, safety controls, safety trip controls, and two-hand controls, presence sensing devices, photoelectrical presence sensing devices, radio frequency sensing devices, electromechanical devices. Pullback devices. Pullback devices utilizes a series of cables attached to the operator's hand, wrist, or arms. They pull the operator's hands out of the danger zone when the machine starts to cycle. They limit the operator's movement and must be adjusted for each individual operator and require close supervision. These devices are usually used on machines with stroking actions. Restraint devices or holdback devices. The restraint devices utilizes cable or straps that are attached to the operator's hand at a fixed point, which prevents the operator from reaching into the danger area. They involve little risk of mechanical failure. Adjustment must be made for the specific operations and for each individual. They require frequent inspection and regular maintenance. They limit the movement of operator and they may obstruct the workspace. Safety trip controls, pressure sensitive body bar. This figure shows pressure sensitive body bar, red in color, located in front of a rubber mill. A pressure sensitive body bar when depressed will deactivate the machine. If the operator or anyone trips, loses balance or is drawn towards the machine, applying pressure to the bar will stop machine operation. The positioning of the bar is therefore critical. It must stop the machine before a part of an employee's body reaches the danger area. This figure shows a safety tripod over a mill. When this tripod is pressed by the hand, the safety deactivates the machine. Two-hand control. The two-hand control requires constant simultaneous pressure by both the hands of the operator to activate the machine. With this type of device, the operator's hands are required to be at a safe location, that is, on control buttons, and at a safe distance from the danger area, while the machine completes its closing cycle. Presence sensing devices. Photoelectric or optical presence sensing devices. In these devices, if the light field is broken, the machine stops and will not cycle. The radio frequency or capacitance sensing devices. It uses a radio beam that is a part of machine's control loop. The design and placement of the guards depends upon the time it takes to stop the mechanism and the speed at which the employee's hand can reach across the distance from the guard to the danger zone. Sensing devices advantages. They can allow freer movement for the operators. They are simple to use. They can be used by multiple operators. They provide passerby protections. There is no adjustment required for different workers. Sensing device limitations. Does not protect against the mechanical failure. They are limited to the machines that can be stopped. Automatic feeding and ejection system can be used as a part of machine safeguards. Automatic feeding systems. Automatic feed reduces the exposure of the operator during the work process and sometimes do not require any effort by the operator after the machine is set up and running. The system feeds the stock to machine from rolls. Advantages. It eliminates the need for operator involvement in the danger area. Disadvantages. Some feeding methods may even create new hazards. For instance, a robot may eliminate the need for an operator to be near the machine, but it may create new hazard itself by movement of its arm. Using these feeding and ejection method does not eliminate the need of guards and devices. Guards and devices must be used wherever they are necessary. Automatic feeding systems require frequent maintenance. Automatic ejection systems. Automatic ejection system may employ either an air pressure or a mechanical apparatus to remove the completed part from a press. Its advantages include that workers don't have to enter the danger area to remove the finished part. Disadvantages of automatic ejection systems are they may create a hazard of blowing chips or debris. Size of the stock limits the use of this method. Also, air ejection may present a noise hazard. Logout and tagout devices. Logout and tagout devices are mostly used during the maintenance activities or repairing activities of the machine. This system refers to the specific practices and procedures to safeguard employees from the unexpected energization or startup of the machinery and equipment, or release of hazardous energy during the service or maintenance activities. That's why they are often referred to as control of hazardous energy. Logout and tagout violations are frequently cited by OSHA during the on-site inspection. Tagout or logout procedures. An effective logout or tagout program should include the following steps. Step number 1. Detailed procedures for the equipment. Begin by making sure that you have identified the equipment correctly and accurately, including its location. Next, determine the correct procedure for shutting down and restarting the equipment. Detail that procedure step by step in written. Consider all the energy sources connected to the equipment. Next step, notify the affected employees. When the maintenance is going to be performed, all the employees that may be affected should be notified. Let them know the timing of the work and how long the equipment would be unavailable. Step number 3. Shut down the equipment properly. Explain the shutdown process in detail. It is not enough to say something like disconnect the machine. Spell out the exact action to be taken and in correct sequence for performing those actions. Like switch off the inlet valve 1, then switch off the outlet valve, that is valve 2. Then in step 4, disconnect all the energy sources. Disconnect all the energy sources whether they include electricity, steam, water, gas, compressed air or others. Also identify the process that will release any remaining pressure or other energies, even like tension in a spring assembly. Now step number 5, verify the lockout. Once you have disconnected all the energy sources, attempt to start the equipment to verify that lockout has been successful. Before you try to start it, verify that nobody is in a position where they could be hurt. Once you have verified the lockout, attach the lockout and tagout devices to the equipment to ensure that it cannot be started without removing the devices. Step number 6. Keep it in force during the shift changes. That is, the equipment must remain in lockout or tagout condition across the shift changes, so the workers arriving at the sites are aware that the equipment is out of service. Maybe the worker at Alpha Piper ignored this step, which resulted in an accident. Step number 7. Bring the equipment back online. When the work is done and all the tools and other materials have been removed, the machine can be brought back into operation. Here again, the procedure should be spelled out with exact steps that are involved, along with correct sequence. For example, you may need to open a particular machine's discharge valve before you open its inlet, so any unexpected steam or water remaining in the line has a place to go out. Now there is a small animated clip prepared by OSHA for the training of workers about the tagout and lockout devices. Let's look at that. This slide enlists some frequently cited problems and minor actions that could avoid these problems. Machine operating without a safeguard. Stop the machine immediately and activate the safeguard. Maintenance worker is cleaning a machine that is operating. He should have stopped the machine and lock it out and tag it out. A robot is operating without a protection barrier. Stop the robot and correct the barriers so that no one else come in its way. Visitor is wearing a necktie and observe a lathe machine. Pull that visitor back immediately and have him remove the tie. An operator is observed disabling the guard. Stop the operator from doing so. Secure the guard and take disciplinary actions. Video ahead contains a small quiz to check what you have retained about mechanical hazards. Now check your answers. Thank you for listening the complete lecture.